Do we want to? Morning, everybody. So I'm Matthew Winter, and this is my colleague, John.
John Huang.
So I'm part of the Global Black Belt team. I'm a specialist in big data and advanced analytics.
I'm part of the Azure CAT team, and I've been working with the APS and now SQL Data Warehouse. Basically, it's go back to the Allegro days, so about 7 years in the making. So we went through the process of taking a Linux product and convert to Windows, and now another cycle of putting an APS system onto SQL Data Warehouse, which is the cloud. So very exciting, challenging projects.
So before we start, how many people in the audience has heard of the analytics platform system? Okay, that's more than what I was expecting. Azure SQL Data Warehouse, anyone used it?
Imagine, how could you make your business more intelligent using data? Where do the digital customers using your services come from? How can you engage them better and improve customer churn? How would discounts affect your inventory and margins? Imagine if you could use data to analyze these questions and intelligently predict outcomes. But each question could take hours, maybe even days, requiring more servers than you have in any on-premise data center. But now, you can use Azure to add unlimited compute power to your questions. Introducing SQL Data Warehouse. The new SQL Data Warehouse service is easy to create and can be launched in minutes. It's the industry's first cloud data warehouse that can grow or shrink to any size in seconds, and which you can use to intelligently answer any question using data. You can easily import data from any data source with automated data pipelines from Hadoop, NoSQL, and SQL databases, IoT, as well as on-premise applications and systems. Then you can easily create reports against it, as well as visualize it. Simply connect Microsoft Power BI to a SQL data warehouse in just seconds. It also unlocks the ability to easily use predictive analytics. Azure Machine Learning can now use petabyte-scale data with applications written in R and Python to analyze customer product recommendations or assess customer churn risk. You can expose machine learning APIs that your apps can call to more intelligently interact with your customers. A data warehouse that can scale up in seconds enables Power BI and Azure Machine Learning to tap into unlimited query power. So you can visualize and explore unlimited scenarios. The power to use data to build intelligent apps has never been greater.
So, introducing SQL Data Warehouse. Essentially, SQL Data Warehouse, it's a fully managed relational data warehouse. It's actually based on top of the same code base as the analytics platform system or the parallel data warehouse module. So we've got 7 years of heritage in actually building a massively parallel processing system, and we've used that from APS and pushed it into the Azure Fabric. And from there, we've done one key differentiator between what the APS is, and that is we've split the compute from the storage. What that means is that we now have a platform that, as it says in that video, can scale in seconds. So if you want to start at 100 data warehouse units, and I'll explain what they are later, you can start easily at a nice small size, and then scale out for your batch processing to 1,000 data warehouse units in seconds and scale back for your normal daily processing. So you no longer have to size your warehouse based on the peaks. Of course, it's also based entirely on the Azure Fabric. So everything that's in Azure has been designed to be fully integrated with the SQL Data Warehouse. Whether that's Power BI, Azure Machine Learning, Azure Data Factory, they all integrate very well with the SQL Data Warehouse out of the box. And of course, best price in terms of public cloud. Now, it's available today also in the Australia region. So it's actually available in 17 regions worldwide. It is in public preview today. We're expecting GA early 2016. Yeah, so we're currently on public preview pricing. Now, as I mentioned, what it does is it gives you the ability to scale out in seconds. So you can start off 100 data warehouse units, and you can scale out to 1,000 data warehouse units. Now, you may ask, how can you actually do this? One option is via the portal itself. Another option is to actually do this via PowerShell. And thirdly, for the SQL people within the audience, you can actually make your change as part of your SQL script. And so if you've got a nice batch script, you want to scale out to do the processing and make it happen quickly, you can do that as part of that script. Now, the benefit of actually being able to have that split compute and storage is not only this, it's also the ability to pause. Now, when you actually pause, what that means is it essentially pauses the compute. It means that you no longer have to pay for the compute. And at that point, all you're paying for is storage. Now, if you think about development, test, UAT environments, this is an amazing cost saver because most of the time you're only using it in a normal daily work cycle. So you can automate the actual process to pause those environments so that they're only available, say, from 8 o'clock until 6 o'clock. And that's a one-third of actually having the cost there 24 hours a day. Now, just to actually quickly demonstrate this, we always get asked, is it really that quick? So let's just go ahead and do it. So the first thing I wanted to do is I wanted to just quickly show you how you can actually create a SQL data warehouse for those people in the audience who've not done it. Now, this is the preview version of the portal. You need to be using this version of the portal to actually do anything with SQL Data Warehouse. You can access that via portal.azure.com. It will work with your Azure accounts. From here, literally just click Compute. Go to Data Storage, and from there we have the SQL Data Warehouse option. Enter a name. We say 400 data warehouse units is the kind of sweet spot to start off with, but you can lower that down if you've got a dev environment, or you can increase that if you believe you're going to need the actual compute resource. Just specify what the source is. From there, we can configure. We can see immediately here, if I go create a new server, we can see all the locations available, and we can see Australia East, Australia Southeast is available today. So let's actually go ahead and scale out an existing warehouse that I have. So currently, I've created an Ignite warehouse for this presentation, and from there, I can click the scale button. It's currently at 100 data warehouse units. And if I wanted to scale that out to, say, 1,000, just go ahead, move the slider, click Save, and say yes. It's as simple as that. A few clicks away from being able to have more processing power. Now, because this is based on massively parallel processing technology, we're not just scaling out compute, we're actually scaling out CPU, memory, and I/O capacity. So we are getting a nice linear scalability in terms of that performance. Now, on average, certainly for the Australia region, it's been taking around between 70, 75 seconds to scale out. So we'll just leave that running in the background while we actually just flip the slides.
So Matt, for those who's not familiar with DW, could you sort of give us an overview of what that means? And as you increase this DW, what are you getting in addition to that? And is there a certain benchmark that you can get from any of those DWs? So we'll know how much performance we get as we scale up.
To give you an idea, yes. Good question, John. So think of 100 data warehouse units as one compute node. you scale out to 1,000 data warehouse units, you have 10 compute nodes. Each compute node in the current configuration is 6 cores, 48 gig of memory in terms of, and then of course the I/O capacity. And so we've literally just increased this from 6 to 60 cores within a single click. You want to add something, John?
Yes, so in terms of performance, each one of those DW or each 100 units is basically a representation of scan rate, a representation of data loading, and representation of data movement among the nodes. So I think that wait for a couple of months, we're actually in the process of publishing the benchmarking for each one of those so you can have a rough idea of what kind of performance expectation you get with that. In the meantime, because we scale out so fast, like Matt said, less than 60 seconds or so, then we typically recommend you start out with DW 400 and run your workload, a sample workload, and then if you need to scale out, you can easily do that. Okay.
Yeah, normally as well, when you're actually doing the slider here, you will actually see the price per hour, and it's in Australian dollars. Roughly, it's about $1.50 for 100 data warehouse units per hour. That's the public preview pricing. So I will come back to that just to prove that it has actually scaled. Okay. So we talked a little bit about that this is based on MPP architecture. So what exactly is that? The easiest way of thinking about this is, so SQL Server today is SMP architecture. Essentially means that you have a single server, single instance, and to get more capacity out of it, you have to scale up the actual compute. Now, with an MPP architecture, we actually scale out, which means that we can keep the actual the compute size at a nice, small commodity pricing. Now, what that also means is, think of it this way as well. As an SMP architecture, if I was scanning a billion row table, I would be doing all that work myself. On an MPP architecture, I would actually be sharing the workload out to all of the compute nodes. So it's not a billion rows that they'll be processing each. It'll be whatever factor of number of compute nodes. So if there was 100 people in this audience today, and I distributed it out to everybody in this audience, then there'll be 1/100th of the actual data per compute node. I'm just going to switch back a second. Well, while we're doing that as well, we can see here that it's now successfully scaled out. I go back. We can see that this is now running at 1,000 data warehouse units. And we can see there, it actually took a little bit longer than the 75 seconds. And it's at 3 minutes on that point. So the other thing to note is that, so APS was based on SQL Server Enterprise Edition. Because we've moved this into the cloud, we want to use the SQL Server equivalent for the cloud, which of course is SQLDB. Now, one of the key reasons for doing this is we have all of the heritage that is available with SQLDB. Now that means that we have a platform that's been available on Azure and has been developing specifically for the cloud for over 6 years. Now that gives us all of the Azure compliance. So when it comes to SQL Data Warehouse getting that compliance, we know that it will actually go through very quickly. We also have the uptime on SQLDB of 99.99%. So we know we have the capability there to actually give you essentially an environment that is always on. Now the other thing that people always question is around SQL Server compatibility. Now, it is true, SQL Data Warehouse is a subset of SQL Server Enterprise Edition today. But when we compare ourselves to our biggest rival, the bookstore in the cloud, with their Redshift environment, the difference, there's some key differences. We are based on an enterprise-grade SQL environment. We have user-defined functions, we have store procedures, we have table partitioning, we have collations, we have indexes, and of course we have clustered column store. We have all of the things that you would want to actually give you good performance specifically for a data warehouse. Do you want to add something?
No, yeah.
The other thing as well is that we're actually working very closely with our partners to actually ensure that we get all of the third-party software tools working with SQL Data Warehouse. Now, it is easy enough. You'll find that most products, all you would need to do is change the connection string and they'll work out of the box. But there are some cases where we have to work with the partner to actually ensure that they will work optimally with SQL Data Warehouse. And today, these are the ones that we've actually been working with very closely. Revolution Analytics, of course, is now part of Microsoft.
One thing I'd like to add in terms of the partner is that we recently worked with Attunity, and they basically certified with us. They basically give you capability to move the data around in almost in a simplified, automated fashion. So basically, think about having your source data from Oracle, from SQL Server, and give the capability to migrate and load the data directly into SQL Server. The product's called Cloud Beam, so take a look at that. And it also gives you capability to provide the hub and spoke architecture and capability. So imagine SQL Data Warehouse as your hub. This is where you put a lot of your centralized data warehouse. You might want to have separate data marts. Maybe one of them might be SQL DB. Other might be going back to SQL Server on-prem. So that can be really, really enabler type of capability for you to have multiple data marts. So I think that's what's worthwhile to take a look at.
Now I know for those that are looking at SQL 2016, they'll know that Polybase is going to be part of that. Now because Polybase was already in APS, we were able to actually see this in SQL Data Warehouse a lot sooner than SQL 2016. So we have Polybase capability giving us the ability to integrate both with Azure storage blobs and Hadoop environments. Now this, over time, will actually we'll be adding the Azure Data Lake and other environments within the ecosystem as well. Now, for those that don't know Polybase, essentially what it's doing is it's providing you the ability to add metadata over the top of an unstructured data. So that might be a set of files within Azure storage blobs. You add that metadata in the form of external tables, and then that gives you the ability to write T-SQL over the top. And we'll actually demonstrate that later. Essentially, using Polybase is actually one of the best methods to get data into SQL Data Warehouse because the way this executes is 100% parallel. Now, just to give you a little bit of a taste of what you would have to do to actually set this up, a couple of things. First off, you need to set up your keys and credentials. Now, this looks very similar to SQL 2016 here today. Once you've actually configured this with your, for example, your Azure Storage Blob key, you can then start to look at defining things like the external data source. From there, we can see that this is of type Hadoop, what the location is, so that we've got the container, and we can see what credential that's using based on the key that we've just defined. In addition to data source, you have the ability to define file formats. Now, what this is doing is it's given the ability to say, I want a central file format that I'm going to use for all of my external tables, just in one location. Now, in this example here, we have a delimited text file. It is gzip compressed. So yeah, we fully support gzip compression. We also support other types of compressed format. So things like awk, RC, and Parquet is coming as well. And finally, we create the actual external table itself. So we see there, we've got the final location. We're stating what the data source is, the file formats that we previously configured on the previous slides. And a key thing here is the rejection. So we actually have the ability to allow for a certain number of errors. So you can state, I want to reject based on number of values. So in this case, 0, so it'll fail on a media of any error. You could, for example, set this up for 100 records. If you know that there's always some bad quality data coming through, you could change the external table to actually allow for that. So you can continue on the load process. The other thing where the reject type is useful for is things like header records as well. If you want to, because currently today there's no method of skipping the header. There will be in the future, but you have to use the reject. Now, as I mentioned previously, this is part of the Azure ecosystem. So it is fully integrated with Azure SQL Database, Azure Data Factory, Azure Machine Learning, Azure HD Insight. And the one thing that I forgot to put on here is Azure Data Lake. So Data Lake is fully integrated with that, and you will have the ability to use Polybase in a couple of months' time to pull data from Data Lake and use that within SQL Data Warehouse. Now, as John mentioned earlier, this is how data warehouse units are actually defined. Now, it's based on, as we say here, a scan rate, a loading rate, and a table copy rate. Now, at the moment, this is being defined, what those values are, and they will actually be published by the GA date. And the reason for that is we want to be able to, as future hardware generations increase, we want to guarantee that that's the performance you're going to get. Now, of course, because we've split compute and storage, this gives you the complete flexibility to define how you actually want your SQL Data Warehouse to perform. Both based on the amount of data, so you're only paying for what data you're consuming, and the amount of performance you're going to get. So we have the ability for you to tweak, to give you like a balanced level of performance, or whether or not you want high capacity, low performance, etc. So if you don't mind queries taking a couple of minutes to run, lower the number of data warehouse units, and they'll still work fine with that volume of data. Or increase the volume of data with the same amount of units, however way you want to actually work that. Now I'm going to hand over now to John, who's going to talk a little bit about some best practices with SQL Data Warehouse.
Okay. Thank you, Matt. So I've been working with Preview. We actually started the private preview back in March, and then recently we approached the public preview. So here are some of the key learning that we got from customers' engagement. First thing is data loading. Getting the data, again, Matt mentioned getting data into SQL Data Warehouse. Right now, Polybase is actually the fastest way for us to get the data in there. So the typical step is to get the data, BC, if it's happening to be a SQL Server, BCP the file out first and get it in the flat file, and then upload into blob using AZ copy using a PowerShell. So for historical load, we use this concept called create table as, which basically does a minimal logging, creating a brand new table. That's fully parallelized. So that's the fastest way for us to get the historical data load. So the syntax basically create table as, and then select star from your external table. For incremental, use insert into. Ironically, it's just as fast as the CTAS is in terms of the performance. So whereas in APS, as you know, we have the concept of distribution within a node. And therefore, the way that we use the DTC, we actually serialize it one distribution at a time. But in the cloud, we don't have the concept there, so therefore, the performance just as great. And then the rate that we're seeing, based on some of the customers and some internal testing, is about 490 gig an hour. This is based on the DW1000 and using the resource class, the extra large resource class. Basically, the resource class is just sort of like a built-in resource pool that we use. And we basically allocate a certain amount of memories, priorities, and therefore concurrency. So, so the next data loading that you can use is the BCP. So basically, you can. The recommendation is that use it for smaller file if you have a dimension table. you'll want to go through the process of, uploading the data, creating all those external table and so on. You can easily use just BCP. And the important thing is that make sure that you have all the retry logic. Same applies as, if you were using SQLDB, right? Making sure that you can retry your logic because you might lose the connections and so on and so on. Rate we're seeing about 30 gig an hour as a single thread. This is coming from on-prem data directly loading to SQL Data Warehouse. The thing about it is that it does not scale as you increase the DWU. The reason being is that it's actually bottleneck on the single client CPU. So therefore, you can obviously increases the number of threads. That will get you the improvements that you're looking for. Whereas in Polybase, increasing the number of threads is not going to help you. The reason being is that a single load actually consumes a lot of the resources. So therefore, you can only, a single load can get you the maximum bandwidth that you have there. Whereas bulk copy, you need to get your improvement, the parallelism, you might want to have multiple parallel threads to catch up with the bandwidth. And SSIS, obviously, if you have existing packages already, you have already complex ETL, you can actually use this. In the background, it uses obviously bulk copy protocol, so it's still bottleneck with the single client that we're talking about. And do increase the timeout. The default out of SSIS is 30 seconds. When we increase it to say 300 seconds or so, that will help with the retry logic and retry. So please do that. The other thing is that we talk about resource class. Use the high resource class as you can without sacrificing concurrency. The reason being is that resource classes actually give you, again, more resources, but at the same time, it limits the amount of concurrency. So therefore, use the resource classes without having to sacrificing other user coming in. And then nice thing about us is that increase the DW. If you want to load fast, increase the DW because it actually scale out pretty well. So if you want to, say, go home early or something, increases the DW, and then you should be done, say, at a 10th amount of time versus a DW 100 or so, right? And then decrease it when you complete, or even pause. So that's something like in the middle of the night, if you have a, say, batch process, loading of data or some kind of ETL, program it within your application to increase it when you load it, and then when you're done, just either scale down or pause it, and then just restart the instance the next morning, say 6 a.m. or something. Some known issues that we have for Polybase is that right now we currently do not support extended ASCII or UTF-16. So if that's the case, then you're going to have to use BCP to load the data in. We will fix that by GA, but right now it's just that the BCP is the workaround. We don't support custom multi-date format. So as you can see from the Polybase, there's a date format in there, but it only applies for a single date. So if you have, say, multi-formatted date or something, YYY MMDD and DD MMYYY, you're going to have to resort back to using BCP. And then, if you have some kind of errors during the Polybase load, right now we don't currently generate the reject file or reject reason. You will have an error message that said this is the reason why you failed, but we don't give you the reject file, so you can just take those files and reload it. So that's some of the limitation. Again, all this is going to be fixed by GA, but just for your awareness. So some number on the easy copy, right? So we typically see about 383 gig an hour. This is the typical corporate Microsoft type of rate. If you have to use Express route or you got better bandwidth, obviously this number varies. And the number also varies by how wide your rows are, compression, ratio type, and so on, and how busy your network is. And then download rate. If you happen to want to, say, load SSIS, say, for a VM, for example, so if you can obviously do that with uploading the data up there and into the blob, and then download into your VM and use SSIS on the cloud. That typically get a bit faster performance and more reliable than using SSIS on-prem. So by coming down, it's actually almost twice as fast with 750 gig an hour. Use NC250X of best performance. When you use AZ copy, that's fully parallelize the files for you. And again, the NC option allows you to specify the number of concurrent network calls. So basically parallelizing the transfer. Schema design. So one important thing about the MPP is that you want to make sure that you design your schema so that you can leverage all the MPP process and ensuring the distribution is well allocated, so you won't have any issue with skew. So some of the things that we can consider is that partitioning, right? So making sure that you partition more, to us, a high priority in terms of data movement versus performance. So archiving type, sliding window, you will get the performance obviously in terms of partition pruning and all that kind of stuff. But for us, and the customer what we see out there, the managing of the data is a high priority. So that's where you can control your granularity of your data, right? So this we'll talk about, what happened if your current day data got corrupted or not able to load correctly. You can easily just partition that particular day out and just reload it. So it's easier that way versus doing it by month or so. And then the other aspect of it is a multi-grain your partition design. So maybe your hot data, maybe have it by day, and then as you get your colder data out there, maybe more than 9 months or more than 3 years, sort of like merge it into a monthly partition type. So you can have all your sliding window, hot partition having that window of daily, and then the colder data, it can be on a monthly basis. And there's obviously some overhead with partitioning, and especially true with the MPP. So we recommend to keep about 500 to no more than 1,000. So that will have less overheads on your performance. Split merge, obviously this applies to SQL Server, but also us too, can be expensive when you have data in there. So we recommend you to think ahead and then create all the partition that you have ahead of time. If you're going to do a split or adding a partition, make sure there's no data in there. That can be cheaper than versus splitting up the partition that has data in which we have to do some data movement. Query performance. So as you know that we have this, the secret sauce for us is the DSQL, Distributed Query Plan, in which we basically take your query and we basically split it up into multi-sequential steps to solve the complex join. So the idea behind it is that any type of data movement can be expensive in terms of performance, especially you definitely don't want to move terabytes of data around to solve your queries. Good thing is that making sure that you have the appropriate predicate so you can minimize as much data movement as you can. But the important thing is that design your schema and your distribution key to ensure that you have distribution compatible with join, so you mitigate the data movement. Again, the same thing with aggregation. Whenever we do an aggregation on a column or columns, if that particular column is not, one of the columns is not the distributed column, we have to do data movement in it. So that's one of the design considerations that you may want to take a look at. And also, again, minimize the size of the data, making sure that your queries have your predicate pushed down where it's needed. Sometimes that you may have to go in there and sort of like rewrite your queries a little bit to ensure that it does the predicate push down in certain complex subqueries. And then SQL plan, right now we exposing you to the estimated plan only. The SQL Server actual plan, we're hoping to have something like that by GA. Same with perf counters. Right now, we're not able to isolate that counters specifically for your database because, as you know, we do share that cluster with SQLDB folks. So we're hoping to have something like that by GA. I think that's one of the what we call query insight. that's coming out that might be exposed to the portals. So, and then workload management, just making sure you design your resource classes and assign, the customer, the user, the end user, and the loading appropriately, and leverages the user resource classes so you can take advantage of all the resources out there. And I think I'm going to talk about the case study. So I'm going to talk about a particular APS customer who recently took advantage of a hybrid architecture by using a SQL data warehouse as a DR scenario. So first of all, who are they? They basically are specialists in data analytics for all the industries. So an ISV providing data analytics to all these banks, financial, retail industries. They basically they start out with credit history for 12 years of data for all the South Africans people. And what they do is that they do the credit risk, marketing responses, customer churn, and propensity modeling for all the financial and the insurance companies. So everything about your credit history, everything about your credit, they would have that information, and the bank and the financial industry would use that information to get to know about their customer. They recently went into a more of a modern transactional basket analysis and customer segmentation and product modeling. So basically what they can do is that they can see what, point of time, you can actually approach a store, and they sort of know what you're likely to buy, so they can proactively send you a marketing text or whatever the case is to your phone, so you can take advantage of that. Again, they started getting more into the retailer, the digital marketing, and of course the reward platform. So on the left side is that they have all the traditional data that you see out there. So they have the OLTP system using Microsoft SQL Server and Oracle. These are the OLTP transactional information that they get from their customers. And of course, they have the batch ETL processing that they do at night, consolidating all the data, grouping the data, doing transformation. And then at the bottom is the exploratory. So these are sort of like the development area that they're looking at, maybe new data coming in, such as social media and so on. So what they have is that about a year or so ago, they bought APS, because basically they have 70 terabytes worth of data. And as they were not able to solve all the query or the performance with their current S&P single box. And then by the time they scale out to say a 48 core or something, that can be expensive. So therefore, APS is really the solution for them to solve all their query needs. So they have an APS system, but then what they need is a DR. Now, traditionally, the way to solve that is that you have to go out there and purchase another APS as a DR. Now, that can be expensive because it can cost hundreds of thousands of dollars. The thing about it is that if you don't use it, if you never go into a DR scenario, you basically have a second very expensive box really not being used at all. So that can be a problem for them. So as soon as they found out about SQL Data Warehouse, they basically just use the way they get the data up there is that they use SQL Data Warehouse as the DR. And again, Matt talked about having a polybase as a way to get the data, extract the data up into the blob. In the middle is that they use this express route. Now the reason why they use that is that, as you know, South Africa, the internet can be very, very unreliable. So therefore, they just went out there and ensure that they have a consistency and the reliability. So therefore, express route is a way to go for them. So they export that data using Polybase, export all that data into the blob. And then again, use Polybase to load the data from the blob into the Azure SQL Data Warehouse. And then therefore, on the right, they can do all that processing over there, querying against it. Now, the other thing they can do is another layer of security is that they can actually perform the backup, not only on the current on-prem APS, but actually store that extra copy of the backup into the cloud. So provide them another layer of protection, leveraging the Blob technology. And at the bottom is a StretchDB. I'm not sure if you guys are familiar with StretchDB. Anybody? Okay. So StretchDB gives you the capability to archive your SQL Server data into the cloud. So what they do is that because the data contain PHI information, so they have to get through the regulatory of South Africa, they cannot keep the data. The data that they have in SQL Data Warehouse, they basically just do not have the Social Security, all this PHI information.
You've lost your mic.
Oh, did I? Is the battery or what? Okay, I'll talk louder. It's right here. So anyway, so StretchDB, what they do is that they actually put all the keys, join keys on the StretchDB. So therefore, what they do is that they physically separate the data, PHI data, from non-PHI data. So then the bottom line is that the data in the StretchDB contain all the joint information that will get them the PHI information. This is a way for them to physically separate PHI data on the cloud. And the other thing is that because they're got the data up there in using SQL Data Warehouse, they can leverage all the Azure ecosystem. Imagine, all the integration with machine learning, the integration with ADF, the Azure Data Lakes, and then it gives them a lot of flexibility in terms of not only doing further analysis on the current data that they have, and it's also potentially could give them a more new business that they're looking at. An example is that they typically right now just publish the model, and then they have to stamp the model and send the customer as a fat file. Whereas now they can basically just publish a model API, and then provide that flexibility to send it to the customer and allows customer to customize that. So basically, more services for them, therefore more revenues for them. So the end is that the APS DR with the Azure Data Warehouse, you don't have to buy a second appliance. I have one already on the cloud. Way cheaper. We're looking at 7 to 10 times cheaper than investing in the APS. Always available, disaster recovery solution. This is the cloud, so therefore I have geo-redundancy, so I don't have to worry about having my system being down. And again, the backup repository is they start leveraging, consolidating all the data into the Blob solution now. So now that they take advantage of getting the data into the Blob, and that's a centralized repository. They can use that as a source to load the data into the APS, or they can use that as a source to load the data into SQL Server and even to the SQL Data Warehouse. So the value proposition is low cost, obviously, for storage, separating the storage and the processing, and reduces, they also have a company policy to reduce the footprint. So therefore, getting the cloud makes sense for them. And then, of course, all the data being exposed to the entire Azure stack, again, leveraging the ecosystem, leveraging all the services being provided out there, giving them more opportunity to make money with the additional data, with the additional tools that they have on the Azure Data Warehouse. Okay? And then the lesson learned from them is that South Africa, typically, they're about 4 or 5 years behind in terms of technology, and it can take them quite some time to convince their business governance to get them to adopt Azure. So that's the thing is that sometimes that technology might be right for you, and even the costing might be right for you, but it's just a matter of convincing the right people to adopt the cloud technology. It can be taking a long time. The other thing is that you have to understand the Azure SQL Data Warehouse architecture, basically MPP. So you need to spend the time understanding how to load the data correctly, how to design the schema, leveraging, picking the right distribution key, leveraging the parallelism of the engine. Or else, if you don't, then you're not going to be able to take advantage of it at all. An example is that if your data happens to be skewed, for example, and everything is processing a single node, you're not buying anything with this, the MPP. The other thing is that traditional data warehouse that we see out there with SMPs, that they typically do a ETL type of processing, whereas with MPP, we recommend you to do the ELT. So load the data into the MPP and let the engine does the transformation. It has a lot of power and a lot of processing. Let it do the work for you. And the other thing is, for this particular customer, they recommend, or what they see better is denormalizing the data. Now, what they're saying is that you don't have to go through the complex of reorganizing, redesigning your data to be star schema, the Kimball method. I mean, if your data are already in the third normal forms, it's how the sheer power of the MPP can pretty much get the data, the performance that you're looking for. Sometimes even better. You have to sort of like abstracting the complex join that you would have, say, with a fact table and multiple dimension table type. This is more or less, the last point is more or less about Azure as a whole, is implement with small project, but have a big goal, have a goal in mind, and it's just everything, making sure that you follow that. Don't try to tackle everything, big thing at the same time. Just take a more small delivery and making sure that you design your architecture and your deliverables around the scope of the project. And that's it.
So thanks, John. So now we're just going to move into a quick demonstration. So first off, what I've actually created, so I'm just going to do a demonstration of how we can stream data into Azure SQL Data Warehouse. So what I've done is I've actually created an event hub. Now this example is designed based on telco data. So I'm looking at the typical call data type scenario. I've created an event hub. I've now, within Stream Analytics here, I've defined the input looking at that event hub. I'm actually setting this up as a pass-through query. So basically, all data from the event hub is going to go out to the output. And if we look at the output here within the Stream Analytics, we can see that that output is labeled as SQL database. And if we actually look into that, it's a single table on the SQL Data Warehouse that we actually just scaled out. Now, I've actually gone ahead and started this because I know that can take a couple of minutes to do that. So let's quickly in the background, let's just take a query that actually looks at the table. We can see at the moment that there's 0 rows. Now, what we want to do first is we actually want to start up a generator. So all I've done now is I'm now populating Event Hub. I'm just going to let this run a couple of seconds. So essentially, we're just pushing data as fast as we can within the connection here up to the Event Hub. All of this is actually stored as JSON. The JSON data is being translated into an insert statement that then gets pushed through to, via Stream Analytics, through to SQL Data Warehouse. Now, if we actually go back, now that's been running for a little while. Okay, it started to come through. It just takes a little while for the data to start to trickle through the actual pipe. Now, if we continue on, if I just continue to run, we can see there, yeah, the data is now actually being pushed through. So we've got 160 rows there. I can quickly, rather than just run the count, just to verify that that data is in fact the data that was being generated. Here's the top 10 data, and we can see based on what was generated here, it looks very, very similar to this kind of data. Now I'm going to leave that running in the background. So that's now, I've got data streaming to the warehouse in the background. At the same time, I'm now going to go ahead and just use Polybase to load some data. Now, what I'll just quickly show here, the first thing I'm doing is I'm defining an external table. So in this particular example here, I'm going to load roughly around 25 million rows. We'll see how long that takes. Now, for anybody that knows AdventureWorks, this is Fact Online Sales. This is the APS data set that we would normally use. This is a lot bigger than the 10,000 rows that you get with SQL. So this is 25 million usually. We just define the external table. So now this is going to go out. It's going to verify the actual Azure Storage Blob connection is there, verify that the file's there, and define the actual external table. Now at this point, that external table is now available for you to run any query you want. So I could run a select count there. I'm not going to, because what I'm going to do is actually pull in the entire data from that storage blob, and I'll show you the storage blob in a second, and create a brand new table, distributed on the online sales key, and this is a clustered column store table as well. So we'll go straight into being fully active query table from that point on. Now, let me just quickly show you the actual data itself. Now, what we have is this. Now, I've actually used SQL Data Warehouse to export the 25 million rows, sorry, not billion, 25 million rows out as a gzip file. Just to demonstrate that there's 60 files here. They're all gzip compressed, and inside that we actually have tab delimited data. And so what it will do is it will look at the folder itself. It will treat every single one of these files as being the same format and load all that data as a single table. Now let's go ahead and load the data. Now, as I say, what this is doing is it's just going out. It's actually parallelizing the process. So it's actually starting to read all 60 files at once. It's actually decompressing and inserting the data into a clustered column store table. Now this will usually take about a minute at this level. But this is, as I say, it's 25 million rows. So it's a good volume. It's a nice test. And at the same time, we are still loading data. So if I quickly just change that back to being a count. Just to show that we can actually run this side by side. There we go. So we're roughly 24 million rows. What was that? 41 seconds? I can now go ahead and query this table just to show that this is actually now loaded. There we go. 24 million rows loaded from Azure Storage Blobs in 41 seconds. It's actually, as I say, it is really easy to use. The recommendation, best practice, is break your files up into multiple files, place them into a single folder, and treat the entire folder as one table. Better performance. So that's just that demonstration there. So now let's integrate with Power BI. Now, one of the data sets that I actually loaded, so I'm actually from Melbourne myself, there's actually a public data set with all of the Melbourne tram stops. So PTV actually allow you to download that from the website. So essentially, what that gives you is it gives you the name, it gives you the identifier, it gives you the latitude and longitude. Now, what I've actually done is I've actually set up a report. Before I actually show you this, what I should do is... So this just to finish that story off, this is actually pulling that data set from SQL Data Warehouse and then visualizing the latitude, longitude of every single tram stop within Melbourne. Now we can go and hover over one of these, and we can see the stop name. Nice, quick, easy demonstration of something visual. And I say all of that stored with SQL Data Warehouse. Now, how do you actually get at SQL Data Warehouse from Power BI? It is as simple as get database, click Azure SQL Data Warehouse, connect, and enter in your details. It is as simple as that with Power BI. They are fully integrated. Now, I've already done that for this particular one. If I go back to my workspace, we can see here that that is all the data. We can see the tables down on the right-hand side. That is all the data that I've actually loaded. Now, as a quick final demonstration, we all like to see performance. Again, I'm going to leave this running in the background. Oh, my copy. Loading while we actually do this, just to demonstrate that you can have data streaming and the performance is fully acceptable. So what I've done is I've provisioned on this environment the AdventureWorks. We can see here we've got a group of dimensions, dim currency, customer date, etc. We've got a couple of fact tables, so fact online sales and fact sales. Now, fact sales is quite a considerable amount of data. So not the typical fact sales that you get. So this is actually 1 billion rows of data. So quick count, so that's less than a second just to count the data. Now, of course, that's not exactly very taxing when we actually think that this particular table, if it comes up, is clustered column store. Clustered column store is designed to count. But there's also just a note there is no partition and there's no additional optimization that's being done here. This is literally just a clustered column store table distributed based on the hash column key, using the power of the MPP platform to actually execute the queries. And that's the same with all of the other tables. There's no indexing, there's nothing actually added onto this. So just to show that there is real data in here, I'm just going to do a quick aggregate just to show the count per year. So we're just joining the fact sales, the billion row data, to date dimension. We're using the calendar year from the date dimension, and we're actually pulling back a count based on that. Now, we saw there that was, 1 second to actually pull that data. But I always get asked, well, that's not exactly complex. So let's do something a little bit more tasking, which would probably be more similar to the kind of queries that you would get. So I'm going to start this off and then talk about it a little bit. So we've got the billion row data. We're joining to 3 dimensions, so customer, geography, date. We're doing an aggregation based on a state, province name, customer type, calendar year. Again, all of these columns are from the actual dimensions. So there's no optimization really that SQL Data Warehouse can do. It's having to perform the join of the 1 billion rows, then do the aggregation, and then move the data based on one of those aggregate columns to finalize that query. And we can see here that, 4 seconds to execute that. And that included, as well as the aggregation, there was a final sort step as well. Now, if you're interested in how Azure SQL Data Warehouse does this, you can literally just add the explain keyword, and that will give you an XML representation of the actual parallel execution plan. Now, just quickly showing you a little bit about this, you can see here the DSQL, or distributed SQL. There's a bunch of steps within here, and each one of those is a different operation. Now, we start off by creating a temporary table because we actually need to move some data. We're going to broadcast, and you can see here we're actually broadcasting some of the dimensions. Now, this is to optimally execute the query. We have to move data. So all the dimensions here are being broadcast to every single compute node at the point of execution. And then finally, there's a step here which is the shuffle move. And what that's doing is it's doing a pre-aggregation step because it's not the final one. And the shuffle move is actually aggregating based on that data that it's got, and it's actually redistributing the data based on state province name. Now it has to do that to actually get the final set of data. It has to move that data. Now that could be 1 million rows of data that we're moving. In this example, it's not, it's actually less. So the pre-aggregation step is actually really beneficial. And then the final piece is the return, where we can actually, now we've actually redistributed the data on something where we can do the final aggregation step. We can do the final return of that data back to the actual client itself. So that was just a quick demonstration of what we actually have today, and I'm more than happy to run anything that you want as part of the question time. But just before we do that, just want to show you this one slide. So the Cortana Analytics Suite. So how many of you have seen Cortana Analytics Suite before? Okay, excellent. So there's a good few people. Essentially, Azure SQL Data Warehouse, it's a key part of the Cortana Analytics Suite. Now, this is the updated slide. So we've got the new icons. We've got Azure Data Lake Store. We've got Azure Data Lake Analytics now. In the previous version, we didn't have that. But essentially, this is the Microsoft vision of how you should be doing all of your advanced analytics in Azure. All of these are platform as a service, so you don't need to manage anything. All you need to do is actually just get your data into the environment and consume. So essentially, if I just quickly run through, we've got Azure Data Factory. Think of that as orchestration. That could actually pull data from on-premise, so you could reach out to your existing systems, whatever they are, whether that's SQL Server, Oracle, DB2, Teradata, Sybase. It'll reach out to them. It can pull the data into the actual cloud for you via a secure gateway. Azure Data Catalog, think of that as metadata repository, simple, and in the future there'll also be a business glossary as part of that. Think of that as being your central place for all of your metadata going forward. So you could pull metadata in from your on-premise solutions. You can add or enrich that data based on your subject matter experts. So you can define, describe, etc. And in the future, that will actually become the actual catalog that's then used by Power BI. So you don't have to actually maintain two different sets of information. Azure Event Hub, we saw there a quick demonstration. Think of that as essentially the easiest way of thinking of it is a queue. So we've actually defined a queue as part of that demonstration. We were loading data in. It can accept data in many different formats. It's the easiest option to get data in real time into the cloud. In the middle column, we've got the big data stores. So Azure SQL Data Warehouse, which is, of course, what we talked about today. Azure Data Lake Store. I'd encourage everybody to actually start to look at the data lake. And it's not yet available in the Australia region, but it will be in the future. But the Azure Data Lake Store combined with the Azure Data Lake Analytics, in my opinion, is a real contender for the alternative to Hadoop. The power of what's actually there, Microsoft has used Azure Data Lake for the past 8 years as part of their Bing and their Xbox divisions. We actually have, internally, 330 exabytes worth of data running on our own Data Lake Store. Now that's actually increasing by 300 petabytes a month. So we know how to scale, we know how to execute, and when we run a Bing analysis on top of that data lake, it's using 18,000 compute nodes. So it definitely can manage any data set that you have today. Of course, all of that is unstructured. So think of the best way to look at it is bring all your data, whatever it is, into your data lake, and then use the SQL Data Warehouse as your presentation layer to that data. On the far right, we have the predictive capabilities. Everybody wants predictive analytics today, or advanced analytics. So we have Azure Machine Learning. We have the Stream Analytics for your real-time analytics. We have the Azure HD Insight to give you any kind of analytics that you want using the open source Hadoop. And of course, we have Azure Data Lake Analytics, which is what we just talked about. And finally, on the right-hand side is the dashboards and visualizations. And before I run out of breath, I'm going to move on to questions. So, any questions? So the quickest way of getting that kind of volume of data is to actually export it onto a hard drive and have that hard drive shipped to the Azure Data Center. We actually have a service to allow you to do that. They call it import-export service. Essentially, it will be there in 2 days. They'll attach it and push the data into your Azure storage blobs. And then from there onwards, you can just use Polybase to get that data in. So that would be perfect for your initial load, but then if you're going to keep your existing system on-prem, then you could use Azure Data Factory or something like that to continually update it. Do you have another question?
The Azure Data Factory which you talked about, can it handle different databases? Other than the database, can it handle other sources as well?
Yeah, so the question is, can Azure Data Factory manage other sources? The answer is yes. So SQL Server, Oracle, DB2, Teradata, Sybase, they're all there today as on-premise sources that can be used. Do you want to take that?
Turnaround?
For the import-export service?
I'm not sure.
Okay, so my understanding is that it's roughly a 2 to 3 day turnaround. That's my understanding within Australia. Any other questions?
Do you know when Data Factory is going to be available in Australia?
Do you have any?
No.
So my understanding is that if you use the Data Factory where it is today, if you're doing anything like copy tables, it's actually already running in Australia. It's only like the metadata piece that sits on top that is actually outside of the region. And so yeah, you can actually see that for yourself and test it out. The data lake, are we allowed to release that?
Soon?
So it's only just gone into public preview. You can do your normal math on how long it takes to go from public preview to GA. Roughly, it will be in Australia around the GA time.
Anything else? Hey.
The governance, the data governance industries related to governance, they would have concerns about putting their data across different locations. How did you address that in South Africa? Is it something that Microsoft brings to the table that says, hey, don't worry, we're safe?
Can you repeat the question?
So the question was, how did you manage the governance for the customer in South Africa? Because it's a government department, I think you said you were from?
Yeah, government.
So how was that managed to actually allow for the data to go to the cloud?
Yeah, so right now, because data warehouse is not, we don't have the, always encrypted data masking and all the stuff that we currently are building in SQL DB. So that's the reason why they separate out the regulatory there is that you cannot have, your transactional data and your, sensitive, PII data together physically. So this is the reason why they separate out having that, PHI information in the SQL Server, and they archive that, or using StretchDB to archive that information separately into an Azure DB, whereas their transactional data is being, archived into the SQL Data Warehouse. And only, unless they have the joint key from StretchDB, the data, in their transactional key is totally, not able to map it back to the PHI. So that's the way for them to get around with the regulatory, unless in South Africa. Did that answer your question?
So in the case of us, we would have to strip all the secret stuff out.
Yeah.
The stuff you want to do work on,
Right.
and then try and get that back.
Right. Yeah. portal?
In Power BI?
Power BI, sorry, yeah. Or would we have to still maintain our existing reporting suite? Because we've got that annoying governance bit of the secret customer source reporting seed.
So I think you can take that in both ways. So all data when it's in Power BI is actually encrypted. So when it pulls the data from the source, it's encrypted. When it comes back to the client, it's using HTTPS. So really, all the rendering essentially is done at the client level as well. So there's an argument to have that there is no security gap with Power BI. But then if they actually want to do it on premise, then using the new features in SQL 2016 and the new release of SharePoint, you actually get a lot of the Power BI capability for on-prem as well. Any other questions? Which version of SSDT supports the warehouse? So I was running Visual Studio 2015 there. The 2013 does support it, but you need the latest update as of, I think it was July.
Yeah.
There's a blog post about which ones you should be using. If you actually just do a quick search for Azure SQL Data Warehouse documentation, there's actually an element there about which version you should download.
Yeah, so right now you have to use a specific version that will support SQL Data Warehouse, but in the future, you don't require us to have that anymore. So if you go search for SQL Data Warehouse SSDT, it'll point you to the appropriate version depending on your version of Visual Studio. So it's a 2015, you need a certain version, 2013.
Yeah.
Can you use SQL Server Management?
Right now, you can use it and do some query, but on the tree, Matt was showing you do a view code, that doesn't work. But again, GA, we're going to have it transparent, so it's going to work on all versions of SSDT, doesn't matter what version, and it's going to work on SSMS. So by GA, Management Studio will work seamlessly.
Quick question about the hardware behind the scenes. We use Redshift extensively.
Right.
Quite transparent about what you're getting.
Yep.
Yeah.
CPU, memory, and so on and so forth.
Right.
With Microsoft, it's a little bit cloak and dagger.
Yeah.
So the only way to compare the two is performance per price
Right.
Yep.
that you get. Can you equate the data warehouse unit to the actual hardware that you're getting behind the scenes?
So you can today, but you have to remember that as the new generations of hardware comes out, we're not going to give you new hardware. What we're doing is we're basing it on the data warehouse units. So what might be 6 cores today might only be 3 cores tomorrow. So you have to use the data warehouse unit metric to get a feel for what that scan rate is, what the load rate is, etc. But it's public knowledge, and you can actually go to the SQL Data Warehouse Connect, and you can actually run sys queries to actually see how many cores and how many CPUs there are. So it is all public knowledge, but think of it as 100 data warehouse units is 1 compute node. 1 compute node has 6 cores, 48 gig of memory today.
The reason why, it's similar to SQL DB, right? We want to keep it, transparent from you what's underneath, because like Matt said, Gen 4 is around the corner, and there's going to be different network card, different CPU, different. So we're just going to keep that. We're constantly making changes in the background. By GA, you're going to see tons and tons of performance improvement also too. So by giving you what we have today, literally next week totally different. So the best way for you to do that is the recommendation is for you to go out and run it. Your performance metrics, and then compare it to the Redshift, and then you saw the idea behind it is that we're going to say we're going to meet or beat Redshift in terms of price performance.
Yeah.
That's the goal.
And I'm pretty sure that if you were migrating from Redshift and you spoke to your Microsoft account manager, they'll match whatever price.
Yeah. Yes, sir.
When you were doing the setup, it asked you for a database name.
Right.
Is it possible to add multiple databases or further databases at a later date?
Yes, you can. So right now, for preview, I believe we set it a limit of 2 databases.
Okay.
But by GA, we're going to lift that so you can have as many as you want to buy.
And you can configure permissions.
Yes, so you can have one database, say 100, and you can have the next database 1,000, just whatever you want it to be.
Yeah.
Yes?
Just
So the question there is you actually want to maintain the encryption as you actually push the data through. So the client itself will actually do encryption over the wire. And we do support transparent data encryption on SQL Data
TDE.
Warehouse as well, or TDE. So, but it will have to decrypt, pass the data over, and then recrypt as part of the load process itself. Now, one of the things that we are going to be supporting, we don't today, is actually encrypted files within Azure storage blobs. So you'll have the means to upload as an encrypted file as well, and then Polybase will actually decrypt as part of the load process.
Anybody else?
Okay, thank you.
Thank you. We'll be around if you guys want to talk one-on-one or something.